Here are four properties of definite integrals that I'm going to be covering. So the first one is the integral from a to b of f of x with respect to x is equal to the negative of the integral of b to a of f of x with respect to x. So as you can see, the difference between these two is that b and a are swapped. So like, let's say a was 3 and b is 7. Definite integral from 3 to 7 is equal to negative integral from 7 to 3. And we already went over this one in the video on the fundamental theorem of calculus, so you should already know this. The second property is that the definite integral from a to b of f of x plus g of x with respect to x is equal to the definite integral from a to b of f of x with respect to x plus the definite integral from a to b of g of x with respect to x. And this is just intuitively makes sense because we already have a rule for this for indefinite integrals. Just integral of f of x plus g of x equals integral of f of x plus integral of g of x. You can just separate them out, and it works in definite integrals as well. So yeah. And the third property, the definite integral from a to b of f of x with respect to x plus the definite integral of b to c of f of x with respect to x is equal to the definite integral of a to c of f of x with respect to x. So as you can see, for f of x, we're adding from a to b, then b to c. So technically, we're adding from a to c, and that's what this is. To give like a visualization, let's say we have a graph like this. This is a, this is b, this is c. And yeah, so a to b would just be this portion. B to C would be this portion, and you can see that since we have A to B and B to C, that just makes A to C, the whole thing. So that's how that property works. And the last one is the indefinite integral of the definite integral, from A to B of C, assuming C is a constant, times f of x with respect to x is equal to C times the definite integral of A to B of f of x with respect to x. And again, this one should make sense because we already have a property for this for indefinite integrals that you should know. So yeah, you can just move the constant to the front and it's the same thing. And now, these rules are pretty easy to get a hang of, so we're just going to go straight into practice problems. If you think you know how to do this one, then pause the video and do it. This problem says write as a single integral, and it is the integral of 2 to 4 of f of x with respect to x plus the integral of 4 to 7 of f of x with respect to x. So as you can see, this is in the form of a to b plus integral of b to c, and as we discussed, it's just integral of a to c. So our a is 2, b is 4, but b doesn't really matter because we don't have a b in our final answer, and our c is 7. So that means from 2 to 4 plus 4 to 7 is just the integral of 2 to 7 f of x dx. And that's our final answer. Now, let's do a second practice problem. If you think you know how to do this one, then pause the video and try it. This one says if the integral of 0 to 2 of f of x with respect to x is equal to 5, 4 to 6 is negative 2, 0 to 6 is 7, find 2 to 4. And we already have that, like the biggest range here is 0 to 6, and as you can see, our intervals are going to be 0 to 2, and then 2 to 4, then 4 to 6. So we kind of split this into thirds. So we already explained in the rules that 0 to 4, 2 to 4, and 4 to 6, all of these added up together have to equal this, 7, because they all add up to 0 to 6. So we can say 5 plus, because 5 is 0 to 2, the integral of 2 to 4 fx dx plus negative 2, because that's 4 to 6, is equal to 7. And then we get 3 plus 2 4fx dx is equal to 7. And then we get the integral of 2 to 4 of fx dx is equal to 4, because 7 minus 3. And that's our final answer. Now, let's do another practice problem. If you think you can do this one, pause the video and try it. This one says, given that the integral of -1 to 1 of f of x with respect to x is equal to -4, evaluate the integral of 1 to -1 and the integral of -1 to 1 of 2f of x with respect to x. So now, let's do A first. And we learned in our rules that if we have these numbers swapped and everything else remains the same, like for this one, -1 is A, 1 is B, and then you can see that this is B, this is A, so A and B are swapped. And we learned in our rules the properties that we can just take whatever this is equal to and then turn it negative, and that's the answer for this. So it's just negative of -4, which is 4. That's our answer for that. Now let's do B. Might notice that we have a constant multiplied by the rest of our function in the inside of our integral, so we can just take that out as we learned in our properties. So we can rewrite it as 2 times the integral from -1 to 1 of f of x dx. And I can notice that this is what we have here, so we can just substitute -4 into that. So 2 times -4 is equal to -8. And that's our answer. Now, let's do one last practice problem. If you think you can do this one, pause the video and try it. This one says, if g of 2 is equal to 4 and g of 3 is equal to 5, evaluate the definite integral from 2 to 3 of g prime of x minus 1 with respect to x. So, as we learned in our rules, we can separate this because this is a function and -1 is a function, so we can rewrite this as 2 to 3 g prime of x dx minus 2 to 3 of 1 dx, and we can just calculate this by visualizing it. We have a graph where our line is just at 1 from 2 to 3. This is going to be 1 unit, so -1. Now let's focus on this part. We can use the fundamental theorem of calculus for this. So first, let's do the integral of g prime of x, and the integral of g prime of x is obviously just going to be g of x. So we have g of x from 2 to 3, so that's just going to be g of 3 minus g of 2. And as you can see, we have both of these values in our question, so it's just going to be 5 minus 4, which is 1. So now we have this equals 1, this equals 1, is going to be 1 minus 1, which is 0. And that's our final answer. So everything that I explained and all the problems that I went through should teach you everything you need to know about the basic properties of definite integrals. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.